enterprise story of the day, which comes from Romaric Redon. He's a DataLab manager at Airbus Defence and Space, and he'll be talking about utilizing deep learning for space imagery applications. Please welcome Romaric to the stage.
Oh, thank you. Good afternoon, ladies and gentlemen. I really thank you for coming to this presentation about deep learning for space imagery application on a little bit more. So I'm working in Airbus Defence and Space. I am the DataLab manager. And yeah, okay, Airbus. I think most of you know the commercial aircraft. Airbus, it is also Airbus helicopters. Airbus Defence and Space, and if we zoom in Airbus Defence and Space, we have military aircraft, we have satellite spacecraft, we have communication, intelligence and security systems, and we have unmanned aerial systems. And yeah, we are not a digital native company, and it's very impressive to come after Netflix, because definitely we started more with building industrial platforms. But more recently, we are going through our digital transformation, and we are also now providing digital platforms, which are cloud-native platforms, providing data as a service and platform as a service for third party to develop application based on data which our platform are delivering. So there is one platform which is the Skywise platform for Airbus Commercial. I won't speak too much about that one today. And there is another one which is called One Atlas, which is for space imagery. And there is a lot of my talk which is linked to this platform. It is linked in a first way because these platforms are providing data lakes. And if we want to do deep learning, we need data, and we need a lot of data. So definitely why we can do stuff now is because we have this enterprise data lakes available, which we can use. And also what we do, and you will see some of the stuff we do, they will be used as software as a service for third party to be used to develop application. And the platform is enabling us to deploy our algorithm as service. So the deep learning journey started in 2014. And with this kind of naive question for industrial, okay, can we use GAFA's technologies and achieve human-like performance for some recognition tasks? And it happens that the answer was yes, we can. And so I will introduce you to the first industrial use case, which was very successful. So you have a satellite image here, and yeah, I have a question for you. There is something we don't want in this satellite image. So something which is not good for our customer. So who has an idea what is the issue with this image? Clouds. Yeah. Yeah, actually, I mean, it happens. I mean, our customers are paying for the satellite image, and if we provide them with lots of nice picture of clouds, they are really not so much happy. So we need to know where are the clouds. And this is not always that straightforward when you have ice, when you have snow, when you have waves. So it happens to be that operators are doing this job. So they are looking at each satellite image, and they are looking for where are the clouds. And they were doing that for years. So quite good setting for deep learning. We were capable to assemble a big training data set with labels. And guess what? We trained a deep neural network, a convolutional neural network, and we were capable to obtain this result, which have a comparable level of performance than what humans operator were doing, and which is very important for us because we are obtaining the result near real time. So we can definitely use that in our process. So this was the first interesting example, and this is now in production. And when we saw the power of deep learning, we definitely embrace the technology. So we were eager to see how we can scale to more use cases and how we can definitely develop and leverage AI, big data skills in the company. So this is why we created the DataLab, which I'm currently managing. So we have two objectives. One is this aspect of having more awareness for the engineers about what deep learning is, and for some of them to become deep learning engineers, because we do have people who are really good at math. They are really good at programming as well. So for them, deep learning is a new blade to their Swiss knife. It's not going to be something they can use for all of the problem, but if they know the way they can use it, they can do great stuff. So this is what we are aiming at. And another stuff we are doing is definitely providing an environment which is mostly based on open source, on GAFA technology, for fast machine learning, deep learning prototyping. So here are some examples of what we've been doing. This is an example of detecting aircraft on airports using deep learning, so building a classifier. So results are quite interesting, even though we do have some errors. But this is, so we did a lot of stuff to detect objects, and this is kind of microservices which are very useful on the One Atlas platform for third party to build application on top of such information to monitor the activity on the airport or whatever. Another example is the boat detection. So here you see also example of some homemade algorithm with below object detection. Also we do segmentation of the image, so we can have the size globally of the ship. And finally, to classify the ship, in this case, an aircraft carrier. It's kind of easy because these are among the biggest. What I want to say now also is that we are fully convinced we can learn a lot from partners. I mean, we are not digital native. We are learning. We try to learn as fast as we can, but we still want to learn from outside. And we've developed ways to do that. So we have developed a platform, which is the One Atlas Sandbox, which is a platform where you can get for free satellite images and also labels on satellite images, so that you can try to build your own machine learning algorithm and also find your business based on satellite imagery. And this has been proven to be very useful. We are working with a lot of startups who are coming with very interesting ideas and technology. So this is the One Atlas Sandbox website. You can just Google it, One Atlas Sandbox, and you will go to it. Also, we are using the Kaggle because sometimes learning about the algorithm is really interesting. So we have, at the moment, a Kaggle running on boat detection, ship detection. So yeah, competition is on. If you want to join, feel free. Now I will go with some other examples which were a bit more tricky for us. So the problem here is detection of change in satellite images. So you have two satellite images which are taken at different time steps. This is a harbor. And in between, we are highlighting the change. But what was really tricky is we want to train the deep neural network to only flag relevant change, trigger alert at relevant change. So in this example, you can see there is a lot of change in the seaside, and we were to train the deep neural network not to detect this change because they are not relevant for what we want to do. And this is kind of tricky, and I will come back to this topic in the perspective. We've been using also a generative model, deep learning generative models. This is an example of going from a satellite imagery to a map. And what is very interesting there is that definitely the map we are getting is not as accurate as a map that would have been uncrafted by a human, but we are getting it near real time. And definitely having something for some kind of application, having something near real time is creating just a new business. So for us, it's really interesting. I will also show some of the stuff we've done, not on satellite images, but this is a video of one of the, it's a video stream coming from one of our unmanned aerial vehicle, which is called the Quad Cruiser. So the Quad Cruiser is making a Coast Guard mission, and definitely we have been capable to implement object detection and object detection and tracking on board of this kind of unmanned aerial vehicle, which is for us very interesting. Last but not least, I mean, this is maybe less fancy, but very interesting for us and very important for us also to apply deep learning to improve our manufacturing processes. So here the topic is about spotting defect in the solar cells. You have solar panels with thousands of solar cells. If we find a way to detect the defect through image-based processing, this is very interesting. And by the way, this is a work which is performed close to Amsterdam in Leiden by the colleagues who are in the room. So what's next? So I want just to open some perspective on the change detection algorithm. Here, what is very tricky for us is that change is subjective. It's very subjective. So we want to move from something which is to build the kind of the best universal change detection algorithm to something which is more, we provide you with a capability to use active learning to build the relevant change detection algo for you. And honestly, we are not yet there. And here I'm pointing to a good talk from Andrzej Karpati. We find that we don't have the right tool set for doing that at the moment, on making quick iteration with feedback from end users, on retraining the model, on all of that. Maybe we are not mature enough on our side, but also in terms of what's getting off the shelf, we are not finding all what we want. Scene understanding is also another important topic to us, because definitely counting, I mean, finding the boats, finding the container, finding the trucks are interesting. But in fact, we want to understand the dynamic of the scene. What kind of event occurred in a harbor? So this requires information fusion, and also it requires to be able to extract behaviors. And there is a very interesting challenge for us, is that we are currently, we are in the process of getting these high-altitude pseudo-satellite, which are solar glider. And this high-altitude pseudo-satellite will deliver video streams, continuous video streams over areas. And this would be extremely interesting with resolution of something with 40 centimeters. So this would be very, very interesting as kind of material to extract information from. Two other topics which are more linked to even bigger challenge. I mean, we've all seen, as you do, the interesting rise of deep reinforcement learning. And we have this issue that we are now building satellite constellation in the order of thousands of satellites. So definitely the unmade rules for allocation are no more optimal. So we need to learn what are the allocation rules. And yeah, we are currently investigating whether deep reinforcement learning is a solution to this problem, knowing that we can build simulation of the constellation. Last is this huge challenge. Airbus has no roadmap for urban mobility. And we have an example of something which is actually existing physically. It's not yet flying. Yeah, our objective will be always safety first. But yeah, we want also to benefit from deep learning and deep reinforcement learning, and we will face transparency, explainability issues very much, and this is more research for us. So conclusion, first, okay, we have built data lakes at scale, and this is a prerequisite to all what we've been doing. We are already doing great stuff with deep learning, We have interesting challenges ahead of us, and definitely we are looking forward to partnering for developing further the technology and the applications. Thank you, and I'm open for questions.
Thank you, Romaric. That was an excellent presentation. Maybe to just kick things off, I mean, clearly deep learning has provided really a step change in space imagery. If you sort of look ahead, what do you think is the next frontier or next step change we can expect in this field?
I mean, deep reinforcement learning is one of the other steps change to really know whether we can embrace the technology and apply it to industrial problems. What we've learned from deep learning is that we have to tweak the engineering mindset so that engineers are engineering the data sets, so they are utilizing their expertise in a new way, rather than coding the algorithm. They are learning to educate the machine through engineering the training data set. But for deep reinforcement learning, they need to engineer the simulation that will be used. And this is really not so easy, but potentially very, very interesting for us. And I was focusing on imagery, but there is a lot of other challenges which are not linked to imagery, which are also important for us in terms of mixing imagery intelligence with other sources of information.
Sounds good. Thank you. Let me open up for questions. Just put up your hand, as always. It's a bit hard to see from here, so I'm going to, if you could stand up if I'm not seeing your hand. Right over there.
Thank you. My name is Eric. I'm managing director of a small company in Eindhoven. You mentioned you're looking for partnerships. Well, what's your definition of partnerships?
There are many, but as I said, we are developing a platform as a service, so we could partner. I mean, actually, there are different models of partnership. One of them is you are consumer of our data that we deliver, and you want to build your own application based on some of the data we deliver, on some of the microservices we deliver. This is one model of partnership. But also on the technology, so this is more on the application side, but also on the technology side. We are fully convinced we have a lot to learn from technology company who are facing the same issues, or who are provider who can help us to move in this kind of machine learning ops. This is DevOps for machine learning, but we have to move to this kind of new paradigm, and we won't get there alone, so we need to learn on these topics from other industry, from other digital native. So, and we are open to set partnership to go faster in our learning.
Sounds good. Any other questions? Please put up your hand. There's one over there on this near the aisle too, actually.
Hi, I'm Michiel from Amsterdam. I was wondering if you also make use of other imagery than satellite images.
Yeah, we are making use of a lot of other imagery which are taken by either unmanned aerial vehicle or whatever kind of device which take images. But in terms of making business, today we are making business on satellite imagery and also unmanned aerial vehicle imagery. So we have a subsidiary which is called Airbus in the US, which is building a similar platform than One Atlas to gather all unmanned aerial system imagery. But this, from a business point of view, this is where we are selling, we are doing business. Internally, I mean, we have a lot of use cases, even for the improvement of, for example, the optical instrument of the satellite itself. We are applying deep learning to try to remove the defect or to be able to remove ghosts from optical measurements. But this is more internal use case. We are not making business with that. We are just reusing expertise on improving our processes.
Sounds good. Yeah, let's take one last question. And if you could keep it short, that would be great. Over there?
Hi, my name is Lydia. I'm from the Digital Society Institute. My question is, do you use adversarial attacks or examples inside your machine learning?
Yeah, we are using generative adversarial networks, and also in terms of adversarial examples. It's an interesting topic because definitely when we see the sensibility of some of the deep learning classifier to such adversarial example, it's something we believe we have to definitely be ready for people that might want to build such adversarial examples. So it's something we have in mind, but as of today, it's quite complex to really build adversarial example. I mean, fooling the machine is not that straightforward, but we know it could happen, so it's something we have on our roadmap.
Thank you very much. I saw a couple of more hands at the back, but I hope they can come and find you during the break.
Okay.
Thank you very much. It was a
Thank
pleasure
you.
having you here. Thank you.